Well, after owning this Edgestar for 3 years, I don't hear any noise coming out of it. Usually you hear a humming, and it stopped cooling. So it's not too unusual for coolers to fail. Either the compressor goes bad, starting relay, or the circuit board components or what have you. So let's take a look. And if you have a cooler, maybe this might give you some tips on how to repair one and not have to spend another $1,200 to replace it. All right. So stay tuned. Let's see what we got. All right. So here we are in the back of this cooler. Now, the things we're going to look at with it not working is the condenser. And it doesn't mean that the condenser doesn't work. It just means that it either doesn't work or it's not getting power. And behind this box here is what is a starter relay and a load protector. The condenser has 3 pins. So let's open up this box. This box comes off. It just unclips right here. You just pop the clip and slide the box out. So let's go ahead and just do that and take that box out, and let me show you what's there, and we'll take it from there. All right, so stay tuned. Okay, now that we've taken the box off to get to the starting relay, it's kind of hard to see with the clump of wires here, but the condenser has 3 pins. One is to go to the load protection, and then the other 2, one is to provide power along with the power coming to the load protector, and the other one is to give it a kickstart to start it on. There's also a starting relay here that goes to, a starting capacitor here that goes to the starting relay, very similar to a house air conditioning system that has a big capacitor there. Typically, that capacitor doesn't go bad too often. It's either the starting relay that's on the condenser. Okay, it's hard to see this clump of wires. So I'm going to take this out and show you what that looks like and how it works. And I'll also show you how to test the condenser by itself. But that's not the only relay. There's also an electronic box here. See where all those wires come in from the front LCD display and everything? It goes to this box. So we'll take this box out if we find that the relay here is good and that wasn't causing the issue. Then we'll take a look at the electronic. In this box, there's a relay that goes into the electronic board in there that also can go bad. So we'll look at that as well. So 2 relays to look at, but make sure we get power. So you can also make sure you're getting power by putting a voltage meter against the top pin and the bottom pin, and also making sure that you're getting voltage, the kick-starting pin. So I'll explain how that works. It's easier for me to pop the relay out and show you this on the relay itself. All right, so stay tuned. Okay, so here's the load protector and the relay that I took off the condenser. Let's see if these are good or bad. So the way this works is there's 3 pins on the condenser. There's, on mine anyways, there's 1 on the top and 2 on the bottom. Okay, and the way this works is this goes like this. Okay, and it plugs into the condenser this way. You can see where the 3 plugs are. Here 1, 2, 3 for the pins on the condenser to plug into. So this top piece here is a load protector. So that gets 120 volts, and it gets it from the circuit board inside. The circuit board, this is what it uses to turn the compressor on and off, because you don't want the compressor on 24/7, and once it reaches temperature you want to shut it off, right? So anyways, so this is what goes to the control board. So there's a relay inside the control board that can go bad as well. It's not just this, and most people don't cover that. So so you need to take that into account. So there's that. Then here's the starting relay. So you have 120 volts that comes in from the control board to this thing, turning this condenser on and off, providing the voltage for it. And then you have another 120 volts that comes in from the neutral. That's this pin here, okay, and that corresponds to this guy there. Now you got 120 volts from the hot to the neutral going to this thing, let's say, if that relay in the circuit board is working and turned it on, but the condenser isn't going to turn on just by that itself. It needs a kickstart. So this pin here will get 120 volt push to it just to get the condenser started, and then it'll shut off. You don't need this constant on. You just needed it just to give the condenser a start. And this is usually hooked up to a starting solenoid or a starting capacitor. So it doesn't get all the energy all at once. The capacitor, kind of buffers it down. So anyways, so this goes to the starting capacitor. Okay. So if you wanted to test your condenser, and please be careful because I'm just talking about my condenser, what I do to test the condenser without these units here is I can make the condenser go on and off by providing 120 volts to the top pin, neutral to the bottom pin on the right, and then a quick jolt of 120 from the neutral to this guy here on the left, just to kickstart. So I'm shorting these two pins on the bottom just to kickstart the condenser. It's a momentary short. You don't want to keep applying power to this pin here, which is a left side pin on the bottom of the condenser. You just want to give it one little touch and then take off, and then the condenser should start. And if the condenser starts that way, then obviously your condenser is good. So how do you test the relay here? This load protector rarely goes bad, okay? The relay here is what goes bad. So how do you test the relay? One way to do it is shake it. There's some ceramic disc, cylindrical, whatchamacallit inside, and that can burn up and crack, and you'll hear it if it's not, if it's not good, you hear a rattle. The other way you can do it is test the connectivity on it. So there should have connectivity between these two pins. So I have my multimeter here, and I'm just going to put it on continuity test. If there's continuity, it'll beep. Okay, so if this is a good relay, which I'm pretty sure it is because there's no rattle in it, and there you go. Okay, so there's continuity. So I'm pretty confident this relay is good. So that leads me to believe that the relay inside the control box is bad. And if that's good, then it goes inside the electronics, and that's just another beast. So anyways, so the relay is good. The load load protector is good as well. I'm pretty sure. There you go, continuity right there. So no issues there. So let's that's the pin coming in. Okay. So let's concentrate on the electronic box and the relay in there, I guess, and see if that's what's causing our problems, because I'm pretty darn sure those are good. Okay, so here's the control board. That's the relay in question. It clicks, but it's not making contact like it should. So we're going to unsolder this relay, put it on the power supply, and test the continuity on it and see if that, ensure that's the case, and then we'll replace that with the brand new relay. All right, so stay tuned. Okay, so I got 12 volts going to these leads here. You should hear a click when I connect the 12 volts to this, and then there should be contact between these two. So right now, obviously there's should be no contact between these two. So okay. Okay, you don't hear anything, no contact. Okay, and these are working. So now you'll hear a click as soon as I apply 12 volts to this. Hear that click? Okay, so now the contact should be making, well, there should be contact here. Continuity, I should say. And there is none. So obviously there's something wrong with the relay. So let's get the replacement in here and make sure that that works. Okay. There should not be any continuity right now. Okay. we should hear a click. And now we should have some continuity. Okay, so that relay obviously works. So that's going to be our replacement. And let's see if that resolves our problem. All right, so stay tuned. Okay, so I got the board connected back in, and the primary result of that bad relay is that it didn't make the connections between the 120 volt coming in and this red wire that goes to the load protector on the condenser. So that relay needed to make these contacts in order to give the condenser the voltage to turn it on. So that bad relay is what caused the condenser not to turn on, because it wasn't getting enough. Well, it wasn't getting juice. It wasn't getting power. All right, so now we got this back together. Let's plug this in and see if that solved our problem. All right, stay tuned. Okay, so I have the board put back into its box a little bit just to keep it from touching anything metal. I have the cooler hooked up to a power strip. I normally don't. Normally it's plugged straight into the wall, but the power strip gives me the convenience of turning this thing on and seeing this thing work. So we should hear a click from the relay, and we should hear the condenser going. I'm going to put the microphone off and put it here. Hopefully you can hear this. It'll pick it up. Okay, here we go. Okay, I heard the relay going off. But I don't feel the condenser going on. Let's see here what we got going in the front. Oh, there we go. Heard something. Oh, there you go. Yeah. Yeah, I feel the condenser going. And yeah, there you go. That's what it was. That relay right there. All right. So let's wrap this up. Let me put this back together and I'll give you a quick summary. All right, stay tuned. All right, after leaving this on for a couple of hours, we got everything back to temperature, 39 degrees on the left and 55 degrees on the right. So I can call this done, all because of this little guy here. So yeah, these things are not cheap. $1,200 for a cooler is a tough pill to swallow when one goes bad. So I hope you got something out of this. Maybe you can repair your own, give you some tips. And hey, like I always say, you only live once, live for the day. Peace out.